Hello everyone. So in this section we will discuss about the physiological phases and its importance. Previously we have dealt with our morphological stages, which includes the bud stage, cap stage and bell stage. So in all the stages we have seen that the cells will be changing from one kind to another kind. So simultaneously, when the morphological changes are happening, the physiological changes also happen simultaneously to ensure formation of a normal tooth of appropriate size, shape and structure. So both morphological changes and the physiological changes go hand in hand. So in the physiological changes or stages, the first stage is the stage of initiation. So this we have discussed in our bud stage also. So the evidence of the tooth formation is observed as early as 6th week of intrauterine life with the formation of dental lamina. So at 6th week of intrauterine life, the sprouting happens. The dental lamina formation begins to form. So that time at 10 different locations, a bird-like structures, the dental placodes will come that we have all discussed, and the deciduous tooth will be formed over there. And then simultaneously permanent teeth also develop from the lingual and distal extension of the tooth bud. So that is all about our initiation. Now in the initiation phase, so this process is the result. What is initiation? So it is where your mesenchyma, that is your ectomesenchyma connective tissue, and your epithelial tissue which is above, both will interact. So when the oral ectoderm, epithelial tissue and the connective tissue interact, that results in the formation of the tooth. That is the very beginning what we have discussed. So the process of initiation is the result of epithelial mesenchymal interaction, and this decides the commencement of tooth formation. And once this initiation begins, when the player 1 and player 2 the interaction begins, then it decides the number of teeth to be formed and the location in the dental arch where the teeth has to come, what should be the number of the teeth, everything will be decided at this phase only. So this is the initiation phase. The next phase, once the initiation is over, then the cells will try to proliferate. So the next stage is stage of proliferation. So in this stage, the cell begins at the bud stage and continues through the bell stage. So we have discussed that bud stage, and again you have got the cap stage, early and late, and then the bell stage, early and advanced. So all these stages, the cells is changing, it's proliferating, enamel organ changes its shape from bud to cap to bell stage, it is changing. That all comes under stage of proliferation. So this process helps to provide adequate cells for further development of tooth germs and contribute to the determination of the shape of the crown. So because of the proliferation, the enamel organ is changing and the shape of the crown is being dictated here. Now this is very vital step. If any defect happens in this step, so if there is any defect happen in this step and the initiation, now defect can happen at the early stage or at the late stage also. If the defect happened at the early stage, then it will result in failure of the tooth germ to develop. The tooth germ will not develop, which will result in less number of teeth in the oral cavity, because the tooth germ is only not there. So tooth germ not there, less number of teeth. That is in early stages of tooth formation if there is a defect. And if there is a defect at the later stages, that will lead to formation of a tooth will be there, but it is defective in size and shape. So it will be a deformed tooth. And if excessive proliferation of tissues take place, then that will result in odontogenic cysts and tumors. So that is all during the late stages of tooth development if there is a defect. So this stage, next is your morphodifferentiation stage. Morpho, so the morphology means the shape. So it is a physiological process that ensures the normal shape and size of the developing tooth happens here. So morphologically the shape is changing and the size of the tooth is changing here. And this process begins in the cap stage and become maximum at the early bell stage. So from the cap stage to early bell stage, maximum morphodifferentiation is taking place. And the process of morphodifferentiation, as it proceeds through different stages, make sure the tooth gum is changed from an undifferentiated stage, that is in the bud stage it is an undifferentiated, to a highly differentiated stage in the bell stage. So that change it will take place from bud stage to bell stage. The change what is taking place is because of the morphodifferentiation. An enamel organ develops an invagination into the deeper parts of the cap stage, which further deepens into the bell stage. So this is all because of the morphodifferentiation stage what is happening here. The shape of the tooth crown is defined and established in the early bell stage. The shape of the tooth is well defined, whether it is incisor, canine, premolar or molar. Whatever it is, in the early bell stage, that is finally decided. And the ameloblast cells are derived from the inner enamel epithelium and the odontoblasts are derived from the dental papillae. So ameloblast will give rise to enamel and your odontoblast will give rise to dentine. So both of them will lead to their formation up to the dento-enamel junction. So up to the dento-enamel junction, enamel and dentin will be formed. So at this junction, the ameloblast, which is lining by inner enamel epithelium, and then ameloblast comes, and your odontoblast from dental papilla, they are separated from a basement membrane that is called as membrana preformativa, or it is called the blueprint also. So that is all we have discussed that. So the process of morphodifferentiation continues in the advanced bell stage during the root formation, and when the Hartwig epithelial root sheath determines the shape, size and number of roots to be formed. So HERS will determine the number, the size and the shape of the root. HERS will decide. Shape of the crown is different. The root is different. HERS Hartwig epithelial root sheath will decide the shape, size, number and roots how it will be. So now if there is any disturbances in morphodifferentiation, so definitely it is going to impact the tooth. So it will lead to abnormal form and size of the tooth. So if the morphodifferentiation stage is not happening properly, if it is underdeveloped, the tooth will become peg shaped. Peg shape means it will be a conical tooth. The tooth will resemble just like one cone. So it will be one conical tooth, a small tooth like one cone, conical tooth. And if at all the tooth are not developed, it will be very small. The tooth will look normal, but they are very small. That is called as microdontia. And then if the tooth are overdeveloped, bulbous tooth, very big tooth, that is called as macrodontia. So the disturbances in morphodifferentiation will lead to peg-shaped laterals, microdontia, macrodontia. Next is the stage of histodifferentiation. So histodifferentiation, it is the physiological process by which the cells undergo morphologic and functional changes to perform their function. So morphology and as well as the functional changes will happen here. And this histodifferentiation stage is the forerunner of appositional activity, and the differentiated cells lose the capacity to proliferate here. So this stage is maximum in the bell stage. Histodifferentiation happens maximum in the bell stage. So there is an interaction between the inner enamel epithelium, which is ameloblast, which will give rise to, and the dental papillae, which will give rise to odontoblast and dentine. So that histodifferentiation, membrana preformata, all those things is grouped under histodifferentiation, what is happening here. So any defect in the histodifferentiation phase will give rise to certain conditions like amelogenesis imperfecta. So here the enamel formation is not proper, it is incomplete or defective. Then vitamin A deficiency can also affect the differentiation of ameloblast. So defective enamel will be formed and defective dentine will be formed. And third, dentinogenesis imperfecta. The dentin which is formed is defective in nature. So you got amelogenesis imperfecta. Vitamin A deficiency will lead to undermatured ameloblast and your dentinogenesis imperfecta. Now coming to the last stage of your physiological stages of tooth development is apposition phase. So the process of rhythmic deposition of hard tissue is called apposition. I repeat, the process of rhythmic deposition, layer by layer, rhythmic deposition of dental hard tissue is called as apposition. So once the dento-enamel junction is established, then the formative cell starts successive deposition of organic matrix which gets mineralized to form the dental hard tissues. The dental hard tissues are your enamel, your cementum, dentin, all those things are there. So any problem happening at this stage, any systemic or local factors that affect the activity of ameloblast, any disturbance at this stage can cause arrest or interruption of matrix deposition or mineralization. First, the matrix deposition will happen and then only it will get mineralized. So, any defect in the stage of apposition, either the matrix deposition or the mineralization will be impacted. So, it will result in defective tooth structure. And since the ameloblasts are highly sensitive cells, enamel hypoplasia is a common condition which happens. Because ameloblasts little bit change in the environment, it will become defective. So if it becomes defective, enamel hypoplasia happens. Hypo means less. So that is all about in this section of your stages of tooth development. So in this chapter, we have discussed about the introduction part, then the morphological stages of tooth development, and then the physiological phases of tooth development along with its importance. Thank you.